Okay, so let's take a look at 5.2, evaluating trigonometric ratios for special angles. It says angles that measure 30, 45, and 60 often occur in trig. Okay, they're sometimes called special angles, and the triangles that involve those angles are called special triangles. There are two special triangles that are of interest. The first one is actually this one here, which is an easier one to construct, the 45, 45, 90 triangle, and the second one is the 30, 60, 90 triangle. So I'm going to show you how to first construct these two triangles, then we'll talk about coming up with trigonometric ratios for those angles. So the first triangle that I spoke about is a 45, 45, 90 triangle. So this is called a right angle isosceles triangle. So if you have a right angle isosceles triangle, you have a 90-degree triangle and where both two side lengths are exactly the same. Now, if two side lengths are exactly the same, that means two angles are also exactly identical. And if I go to label these two angles, they both have to be 45 degrees because we know that all angles add up to 180. So this is the only way that this is possible. Now, what should I call this side length? I can call it anything I wish. I can call it 10, 5, 4. I can even call it 1. 1 is the most simplistic number, so I'll call it 1. So this is a 1 unit, and that means this is also 1 unit. So you have a triangle that is easily constructed without even doing any work. But what is the measurement of this side length here, the hypotenuse? Well, I know that c squared is equal to a squared plus b squared. So c squared is equal to side length, well, actually not c squared, but x squared is equal to side length 1, which is 1 squared, plus side length 2 is 1 squared. So x squared is going to be equal to 1 plus 1. So x squared is equal to 2. Or I can take the square root of both sides to get rid of the square. X is equal to the root of 2. So I know that x is equal to the square root of 2. So this is the triangle of 1, 1, root 2, where the angles are 45, 45, and 90. Exactly what I have here. I can construct that and explain that construction on my own. Let's construct this one here. That one there is a little different. It starts off by, let's say you start off with an equilateral triangle. Now, if you have an equilateral triangle, you understand that all side lengths are the same. And if all side lengths are the same, that means all angles are the same. That means this is 60, this is 60, and this is 60. It's the only possible construction of an equilateral triangle. Now, what should you call each of the side lengths? Should we call them 1, 2, 3, 4? You can call it whatever you wish. I'm going to call them all 2 because what I'm going to do next is I'm going to cut this triangle in half. So I'm calling them all side length 2. You can call it anything you wish, but I'm going to call it 2. Now, if I split this triangle right down the middle here and cut it in half, what happens? Well, if I split it in half, this ends up being 90 degrees, and this bit here is 30 degrees, where this is 2. And now this bit from here to here is actually 1 unit. Now, the reason I didn't call it 1, 1, and 1 is because when I cut this in half, this would have been 0.5. So I called them all 2 so that when I cut it in half, this would be 1. So if I draw the triangle right underneath it, the 90-degree triangle that I cut in half, I cut the equilateral triangle in half. Again, this is 60 degrees, this is 30 degrees. This was side length 2, this is side length 1. And we can come up with what this is right there. So I'm going to come up with what this is here, this side length here. Again, c squared is equal to a squared plus b squared is the Pythagorean theorem. And if I plug in the correct numbers, your c value is 2. So 2 squared is equal to side length 1, which is, let's say, x squared plus side length 2, which is 1 squared. So 4 is equal to x squared plus 1. If I bring the 1 to the other side, I'm going to get 4 is equal to 4 minus 1 is equal to x squared. And so I'm going to get x squared is equal to 3. And I can take the square root of both sides, so I get x is equal to the square root of 3. So this is root 3. So this side length is root 3. So cross from the 90 is 2, across from the 60 is root 3, and across from the 30 is 1. So that's how you construct this triangle here. It came from an equilateral triangle with side lengths 2, and it was cut in half. So now let's take a look at, after we have these special constructions here that we can come up with without a calculator. Notice I kept this as root 2 because root 2 is not a nice number. Root 3 because root 3 is not a nice number. It asks us to use this information given in the two special triangles above and fill in the exact solutions in the table below. And what I want to do is I want to come up with the sine of 30, 45, and 60, the cosine of 30, 45, and 60, and the tan of 30, 45, and 60. So I'm going to do that. First, I'll start off with 30 degrees. So I'm going to first find my 30-degree triangle. This is 30 degrees. Now, this is 90-degree triangle, so I can use SOHCAHTOA. According to my 30-degree angle, this is the hypotenuse, this is opposite of the hypotenuse, and this is the adjacent. So according to 30 degrees, hypotenuse, opposite, and adjacent. Now, if I want to come up with the sine of 30 degrees, remember that sine is opposite over hypotenuse. So sine of 30, according to this triangle, is the opposite side, which is 1, all over hypotenuse, which is 2. So the sine of 30 without a calculator is 1 over 2. Now, if you used a calculator and you did sine of 30, it would be equal to a half. Now let's take a look at cos of 30. Cos is adjacent over hypotenuse. And cos of 30, according to this triangle, adjacent is root 3 over hypotenuse is 2. So adjacent is root 3, all over hypotenuse is 2. So if I do the cos of 30 on my calculator, and I remember that answer, it is exactly the same as root 3 divided by 2. This is a precise answer, exact answer, not rounded, root 3 over 2. Now notice that it says that no radicals could be in the denominator of a fraction. It's okay for the radical, a square root sign, to be in the numerator, just not the denominator. Let's continue on. Tan of 30. I know that tan is opposite over adjacent. So if I go to find tan of 30, I get tan of 30 is equal to opposite, which is 1, all over adjacent, which is root 3. So this is tan of 30. Okay? And if I did tan of 30, it would be the exact same as 1 divided by root 3. Now, just look at the denominator here. The denominator has a radical, and that is not a proper way of writing a fraction. A fraction can never have a denominator as a radical. It could have the numerator as a radical, but not the denominator. So what we're going to do is called rationalizing. So we're going to rationalize the denominator. Okay? So we're going to rationalize the denominator. How do you rationalize a denominator? Well, let's take, for instance, this tan of 30. We know it's 1 over root 3, but that's not the proper way you'll have written in the back of your book. So in order to rationalize the denominator, remember, you can multiply both top and bottom of a fraction by whatever number you wish. Okay? So what I'm going to do is I will always, to rationalize the denominator, multiply both top and bottom by what the denominator is. In this case, it's root 3. I'm going to multiply both top and bottom by root 3. What will happen is on the top, you will get root 3, because 1 times root 3 is root 3. And on the bottom, root 3 times root 3 is the square root of 9, which is 3. This is what the back of the book will have written, root 3 over 3. Okay? Because the bottom can never be a radical. If you do tan of 30, it's the same as root 3 divided by 3. So now you can fill in these. Sine of 30 is a half, cos of 30 is root 3 over 2, and tan of 30 is root 3 over 3. And we did this without a calculator. You didn't need a calculator to do this. Okay? I'll do the 45s as well. Okay, so the sine, cos, and tan of 45. So according to this 45, which 45 you use, it doesn't matter. So I'll use this 45 here. According to this 45 here, this is your opposite side, this is your adjacent side, and this is your hypotenuse. Of course, you can use this 45. Doesn't matter. And now, if we come up with the sine of 45 degrees, we know that sine is opposite over hypotenuse. The opposite is 1 all over the hypotenuse is root 2. Remember, this is not a good answer because you have to rationalize the denominator. You cannot have the denominator as root 2. So what do? I multiply both top and bottom by root 2 so that I make sure that the bottom number, root 2 times root 2, is root 4, which is 2. And the top will be 1 times root 2, which is root 2. So this is the sine of 45. And if I did sine of 45 on my calculator, it would be equal to that. The cos of 45. The cos of 45 is adjacent over hypotenuse. And the adjacent is 1 all over the hypotenuse is root 2. And again, same thing like this one, I'm going to have to rationalize the denominator. Again, multiply both top and bottom by what the denominator is now. And you will get that times that is root 2, and this times this is just 2. So cos of 45 is actually the exact same number as the sine of 45. And then tan of 45, we're going to get as opposite over adjacent, and opposite over adjacent is 1 over 1, which is just equal to 1. So if I did the tan of 45, it's going to give me 1. So I know the sine of 45 is root 2 over 2. I know the cos of 45 is root 2 over 2. And I know the tan of 45 is 1. And this is without a calculator. We're going to start doing these things without a calculator. I will let you do the sine, cos, and tan of 60 degrees. You can use your book as well. But just remember, you will be using this triangle here, but you will be labeling the triangle according to the 60 degrees rather than labeling it according to the 30, where this will be opposite adjacent hypotenuse, and you can figure out what the sine, cos, and tan of 60 degrees are using this triangle here. So you got to be able to construct these two triangles, and you got to be able to find the sine, cos, and tan of all three of those angles, 30, 45, and 60, and that is without using a calculator. These are exact answers. And this will also help you find different angles that go that are between 0 and 360 degrees when we start doing other sections.